The LG Procast is intended for informational and entertainment purposes only. The views or opinions expressed by the podcast hosts and guests do not necessarily reflect the official position of LG. For the latest and most accurate information about LG products, please consult relevant product manuals and related documentation.
Welcome to another episode of the LG Procast. I'm Philip Craigbaum. Normally I'm joined here with Terry Fresenda, but unfortunately Terry couldn't join us today. He's at home making preparations for Hurricane Helene, so it's just going to be myself, but thankfully I'm joined with our guest today, Mike Molinari from Dytech. Mike, thanks for being here.
Thanks, I appreciate it.
So Mike, we want to talk about power, surge, and you guys have a pretty cool device called the CoolGuard 2 that I want to get into a little bit later. But, kind of funny, we're talking about hurricanes coming up and all the craziness that goes on with power. And you guys are right there next to it as well. You guys are in Largo, right outside Tampa. Is that right?
That's correct. Yep.
Yeah. So go ahead, give a quick introduction about yourself and Dytech, and
Sure.
we'll dive in.
Sure. I'm Mike Molinari. I'm the Director of Business Development here at Dytech Surge Protection. I've been with the company 19 years. It'll be 20 years in February, believe it or not. So we're located in Largo. We do actually manufacture product proudly still here in the U.S. That's where the CoolGuard is made, which we're going to talk about a little bit later. But after doing surge protection for every day of my life for the last 2 decades, I've just kind of seen every kind of power quality issue you could imagine and help folks get through that and come up with solutions. So I'm real happy to be on this today and appreciate the invite.
Awesome. Well, thanks again for being here. So we want to get into how power affects HVAC systems. You know, one of the feedbacks that I get from technicians, and you hear it, I guess one of their gripes that I hear sometimes is, man, the boards always are going out in those inverter products. You know, I had to replace a board on this one. I had to replace a board on that one. You know, and my feedback to them is boards don't really die very often. Usually there's an external circumstance that causes that. Would you agree with that?
I would, and I would definitely say from my own experience, I didn't really hear much about HVAC issues 20 years ago with air conditioning systems just, dying after 6 months due to power quality problems. It seems to be in the last 4 to 5 years, it's been much more prevalent. And each month that goes by, we just hear about it more and more. And I think that's due to more inverter boards being used and an antiquated electrical grid. The electrical infrastructure in the U.S. is quite aged. Now we're really taxing it. It seems like EV chargers are getting installed left and right in people's homes, and we haven't kept up with upgrading the grid itself. So it just lends to a perfect storm, no pun intended, with Helene coming, but a perfect storm of power quality issues for ultra-sensitive electronics like inverter boards.
Right. So maybe let's get into the weeds just a little bit and explain to us what happens. You talk about power quality, maybe unpack that a little bit.
Yeah, so it really, how we started with everything is the surge world. Okay, so transient voltage and spikes, and these are anomalies that are in the thousands of volts for very brief amounts of time, right? So surge protectors, just standard basic surge protectors that you might have used or might have seen in the past, are really for those high voltage spikes, everything above, let's say, about 150 volts line to ground. So it's really there to act as like a pressure relief valve for those events. But what happens and what we've noticed with inverter boards is they don't like over voltage issues, and they sure don't like under voltage issues. So when that line voltage is out of range for too long, that's where we see a lot of the wear and tear on the boards and the premature failure. So that's really where the power quality comes into play. It's not necessarily a transient voltage or spike, which you do get in regions that have high occurrences of thunderstorms, et cetera. But power quality issues tend to be nationwide. Anywhere that's got an electrical grid is going to suffer the same type of problems. And that's kind of what led down the path of creating a product like the CoolGuard, is because it's just becoming more prevalent.
So when you talk about over voltage and under voltage, maybe you can explain a little bit more what happens to the board in each of those situations. What does it actually do to it?
So I believe, and now I'm not a ultra geeky electronics engineer, but we have ultra geeky electronics engineers on staff here that I've talked to in depth. So I believe with a lot of the undervoltage situations, heat becomes an issue. So you have electronics trying to work harder with a lower nominal input voltage. And I think over time, if that happens too long, it's just a factor of wear and tear on the traces, the chipsets. They're just not designed to operate outside of a certain range for too long. And I think that's probably the biggest culprit. You can probably make a case for the overvoltage as well. It's just too much voltage for too much amount of time. And I would imagine heat becomes an issue at the board level.
I gotcha. So, a lot of technicians put surge protectors on their equipment. From what I'm hearing from you, that doesn't sound like it's really going to be an adequate amount of protection.
No, my personal opinion is that we're well beyond just standard surge protectors at this point in the game, right? And standard surge protectors were fine for single stage unitary systems. You have your, $100 surge protector that sits on your disconnect, got a little green or red light on it, whatever. And, that's what you put on there to protect against those major spikes. But anything like a mini split or an inverter driven system, high efficiency system is going to have some degree of sensitive electronics. And I don't think a basic surge protector cuts it anymore. I really think the industry standard should be an appropriate voltage monitor to make sure that you're reacting in real time.
Well, and I can't really even think of any product of any brand in the HVAC world that doesn't have some sort of a board on it. Even your most basic stuff now has got a defrost board or some sort of an electronic board on it. So it seems like it would make sense that this is just standard practice. Every system that goes in really should have something to protect it.
Yeah, and to your point there, I'll give you a little anecdotal evidence. I live in a neighborhood of about 310 homes here in Palm Harbor. And I've got a 6-year-old daughter that I take on walks all the time. And I have counted in my own neighborhood the amount of surge protectors that are installed on somebody's disconnect that's feeding the condensing unit. I've come up with 11 out of 310 homes. So you would think it's a no-brainer. You would think it's standard practice, but I think our industry is grossly underserved when it comes to the education on surge protectors. I don't feel it's that the homeowner says no, it's that they're never educated during the proposal process. So they don't even get a chance to say, yeah, I would absolutely like to protect the most expensive appliance I'm going to buy. You wouldn't really think twice about plugging your brand new TV into a surge protector before you plug it in the wall. But it defies all logic that you would skip the surge protector for a $15,000 air conditioning system. And the sad truth is the homeowner ends up learning the hard way that there was something that could have protected them when their system does go out.
Yeah. I mean, I look back at even in my career when I was first getting into this trade and selling systems, to homeowners, we didn't offer surge protections unless it was on one of our most high end systems. But looking back now and I think about it, I'm like, goodness, it really should at minimum have been offered to the homeowner. I mean, what a shame that we didn't even tell them, right? Mm-hmm. I didn't even tell them, hey, I can add $120 to this system and actually give you some protection for it. I wish we had, but maybe we can help some other guys now go, this is something that I need to look into. But to your point, 3 out of 300 got surge protection. Any of them have voltage monitoring protection
not
like
my
you're
house
talking
does.
about? Right, yeah, I'm assuming yours does.
Yes. No, I haven't seen a voltage monitor on there yet. And honestly, a lot of them are newer systems and, 4-ton, 5-ton units that are extremely expensive. And it's just, you have to think beyond just the cost of replacing the equipment. You have to look at the comfort level. So the air conditioner goes out in the middle of August in Florida, that house is going to get up to 88, 90 degrees real quick. And if that board's on back order and they can't get it fixed for 2 weeks, that's a miserable 2 weeks with your family with no air conditioning. So it's not just the, solution to protect the equipment itself, it's to protect your comfort level. You don't want your air conditioner going down. I mean, it's one of the most important appliances in your home, if not the most important.
Right. And you look at it from a contractor standpoint. I mean, okay, so maybe the manufacturer will warranty the board for you. Fairly likely they might, but somebody's still got to go out there and install it. Yeah. The homeowner's got to sit there for a day, 2 days, however long, uncomfortable. And all of that could have been avoided by putting in the proper protection up front. So, I mean, as a contractor, the guys that are listening to this podcast and watching us, this just makes sense for you to offer it to your homeowners, and in my opinion, it just becomes part of the job.
Yeah. Truth be told, a lot of the contractors, sorry to cut you off there.
No, you're good.
That was a good point you made. A lot of the contractors that we deal with, especially locally, just bundle it into their package. They don't even separate it out for line item because it cuts down on warranty claims and it makes everybody happy in the long run. And if you're a technician or if you're a salesperson with an air conditioning company, I'd encourage you to reverse the roles. Think about yourself as the consumer, and you hire somebody to come out and make a recommendation on a very expensive system. You would expect that they would at least mention, here's something we highly recommend for your area. It's up to you whether to choose, it's your choice whether or not to proceed with it, but at least put the onus on me to decide for myself. I don't want to find out 3 months later by doing a Google search that there was a product that could have saved me. And that's what I would encourage every salesperson, anybody that's forward facing to the customer, just have that conversation. The worst they can say is no, but at least you brought it up.
So if you're a technician and you're out there seeing systems every single day that don't have any kind of protection on them, that is an upsell opportunity every time you see any brand, whether it's LG or anything, right? So, hey, Mr. Homeowner, I just want to bring this to your attention. I've been educated a little bit more about, some power issues. Not saying you have to buy this, but hey, there is something that we can do to add a layer of protection to that pretty expensive unit. I know we put it in 2 years ago for you, but and we didn't tell you then, but I'm telling you now. But hey, let's get into the CoolGuard 2 that you guys have. Tell us a little bit about how that came to fruition and how it works and what it does, and let's talk about it.
So in early 2020, right before the whole world ground to a halt, we were approached by a local distributor of ours and asked us if we would be willing to design and engineer and manufacture a voltage monitor. This distributor had sold plenty of our standard surge protectors, and they were selling a voltage monitor from a different company, and they felt it had a few shortcomings. One being the cost, another being how hard it was to calibrate. It wasn't really, appealing as far as reselling to the customer because of the price. So they said, could you guys design something with these wish list items? And they came to us with a list of about 4 or 5 items, and number one being cost efficient. So we had to keep that in mind when we looked at designing it. So we went to the drawing board, had a little hiccup in March of 2020, got back on it in about July of 2020. And brought in a couple of distributors, brought in a few local contractors, and said, hey, what do you like about this type of product? What don't you like? And it went through a couple of iterations. And the cool thing about designing and manufacturing product right here in the US was the ability to do that. We didn't just lock ourselves in a vacuum, come up with a solution and launch it to the industry and say, here you go. We had a few missteps and folks that said, it would be really nice if you could do this or change that. And we listened. And the fruits of that labor, along with a fantastic engineering team here at Ditech that accepted the challenge, fruits of that labor was the CoolGuard 2. And if you'll allow me, I can kind of give you some in-depth details on why that's a great solution for voltage monitoring.
Oh, absolutely. That's why I wanted you here today, so that we could get into the nerdy stuff. I want to hear about it, what it does.
Absolutely.
in more detail.
One of the big things with the voltage monitors, one of the gripes essentially was how hard some of the models are to sit out there and calibrate. And what I mean by that specifically is if you're trying to find the perfect nominal voltage for your system, at any given point of the day, that nominal voltage can fluctuate. When you get your meter out and you're measuring at your disconnect, looking for your 240 volt, depending on the load conditions, not only on the grid, but inside the home, that number can fluctuate. It might be a little higher at night, it might be a little lower during the day. So the challenge with doing it that way is you find your nominal voltage at a point in time, and then you're trying to build a percentage window around that number, okay? And sometimes that could take an hour or 2 out in the field. And that eats up a lot of labor time when you sell somebody a voltage monitor and you're sitting out there for an extended time trying to calibrate it. So I'll give you an example. So let's say, you measure your nominal voltage and it's on the low end, maybe at 228 or 230 line to line, right? And you say, okay, I'm going to build a 5% plus or minus window around this, and I want the unit to cut off if it goes +5 or -5. Well, you are already on the low side of your nominal voltage. So what tends to happen in those scenarios is you get nuisance trips, because as your nominal voltage fluctuates back up near real normal, it starts to hit the upper limit of what you calibrated on your voltage monitor. So now you get a customer that's calling saying, hey, my air conditioner is shutting off like 8, 9 times every day. What's going on here? And you come to find out that it's nuisance trips. It's not necessarily over voltage. It's just at that moment in time, you captured a very low point, right? So we decided to do our monitoring a little different. So instead of measuring line to line, we actually monitor each phase independently. So in a standard US voltage system, your range on phase to ground is going to be 114 volts AC to 126 volts AC. And that's known as voltage range A. And you can reference that in AHRI 110 is where your voltage standard table is, okay? So that's what the utility company can give you on each phase to ground. So you might say, okay, well, your product should cut off at 126.1. Well, not so fast. So if the utility can give you up to 126, you have to allow for a little bit of wiggle room, or else you're going to be fighting with the utility company, because that nominal voltage does wobble a bit. Even though it's incredibly fast, and it might be a few cycles out of every 60 cycles, which 60 hertz is 60 cycles per second, it might only be a few cycles. So we had to figure out, okay, what voltage range are we going to go with that's good for most instances? The CoolGuard 2 isn't perfect for every application, but it's perfect for most applications, right? So what we decided on was a range on each phase of 104 on the low to 130 on the high, okay? And the reason why we chose that is we looked at voltage range B, which, if you want to check the AHRI 110 standard, it's 104 to 127 on each phase. So first we had to pick what voltage range we were going to look at, and then we had to decide how fast we were going to react to a change. Well, we decided that speed was paramount, and we measure every single cycle out of a 60 hertz sine wave. So this thing is counting every of those 60 cycles per second. If either phase goes low or high outside of that range for one cycle, it's game over for your power. It's cutting it off. And after a bunch of trial and error, we decided that let's open the window just enough to allow for a bit of wiggle room, not enough to necessarily damage the equipment, but make it so fast that either phase, it's going to trip. And the 130 to 104 seems to be ideal for most inverter boards and most mini splits. So the calibration question, the wish list item was, how could we do a plug and play, turn it on and walk away type of unit? So we pre-programmed the voltage range into the CoolGuard 2. And we also, by measuring each phase independently, we allow that device to be installed not only on 12240 split phase, but 12208 split phase. Because if you're pulling 2 phases off a 3-phase panel, you have 208 nominal between your hots, not 240. So in a line-to-line device where you have to calibrate, that's 2 different scenarios that you have to calibrate for, where the CoolGuard you don't. You wire it up, both your phases in, both your phases out, ground in, ground out, put the cover on, turn it on, and you're good to go.
It's that easy, huh? So you mentioned something, and I just want to back up for people who may not be super familiar. You mentioned when it gets out of range, you said game over, it kills the power. Mm-hmm. Maybe let's explain where this device is located in conjunction to the power.
Yes. To the unit. It's going to wire in series with the whip between the disconnect and the unit outside. So it'll either be your condensing unit or your mini split. Okay, so it does wire in series. We decided to use polycarbonate to make it NEMA 4X and non-metallic. So coastal communities, it's fantastic because it's not going to rust like a NEMA 3R steel. So that was one of the other items saying, okay, well, how can we do this without being in a big old gray, ugly box? So we decided to go with polycarbonate, which holds up fantastic, not only in the sun, but in the salt air as well. Okay. So it very simply, you're going to remove the whip from the disconnect, put it to the cool guard, and then create a little jumper whip from the cool guard back to the disconnect. So it's intercepting the power. And what happens when I say game over, kill the power is the relays are going to open. And we decided to build in two options for the delay, basically your short cycle delay. You can select the power to be off for 3 minutes, or you can do 30 seconds. Me personally, I like the 30 seconds. That's the one I have set at my house. I didn't feel I needed a full 3 minutes with the power off. I think 30 seconds is just fine. If the power hasn't come back within range within 30 seconds, I probably have other issues going on. Either the power's completely out in the neighborhood or a transformer's got some issues. I'm calling the utility or I'm calling an electrician at that point. You know, with the enclosure being so important, some of the other units on the market are, again, big gray boxes with a danger symbol on it. The vast majority of homeowners are not going to go inside an electrical box to look and see what's going on with their voltage monitor. So we decided to go ahead and use an LED coding system with a decoder right on the front of the cover that stares at you. So the lights are visible outside the unit. You don't have to open an additional enclosure, so you can always see what condition is present. 2 solid green lights are good. If you have any type of flashing combination of red, that's going to tell you you're in a fault, and that's going to lead you down a path of something's wrong, my voltage is out of range, what's going on here? And that's the entire intention. Not only is it supposed to save the equipment by cutting the power, but it's to alert you that there's a problem that you need to address.
Right. So, power gets out of range, it turns power off to the whole system. And one of the awesome things about an LG inverter system is all of our indoor units are powered through the condenser, which means that one box protects the entire system. I mean, that could be up to 8 different indoor heads if you have a large system like that. So
yes,
one small box and you've protected the entire system indoor and out.
Yep, and it'll handle up to 40 amps continuously. So any system with an MCA of 40 amps or lower, you can absolutely run through it. And in this day and age, I mean, for residential systems, you're going to be hard pressed to find an MCA that's higher than 40 at this point. I mean, with all the inverter systems and the mini splits, you're not going to come close. So you can cover a wide range of products with the KG2.
Well, Mike, I appreciate it. I've learned a bunch here today. Anything that you want to throw at us before we wrap up? Anything that we've not talked about?
Yeah, I mean, going back to just educating the homeowner, just make it part of your standard operating procedure. Just bring it up. Again, this, for the vast majority of people, this is going to be the most expensive appliance that they're going to purchase. And more often than not, they'll go ahead and say yes if it makes sense. This is not a multi-$1,000 product. I mean, it's a few $100. And to protect a $15,000, $16,000, $17,000 or more in some cases, it's kind of a no-brainer. But, they're looking up to you to educate them. They're not educated on what power quality issues are and why you need a voltage monitor. So I'd encourage everybody, just at least bring it up and let the homeowner decide for themselves.
Yeah, I couldn't agree more. So yeah, guys, check them out. Talk to your local distributors. Again, it's called the CoolGuard 2. It's made by a company called Dytech. So if your distributor is not currently carrying that, have them reach out to Dytech, see about bringing that product in for you. But be offering it. Mike, I appreciate it. I've had a great time with you. Thanks for being here. Guys, join us for the next episode of the LG Procast, and we'll see you then. Thanks.